Okay, my name is Srikantha Herath. I'm originally from Sri Lanka. I came to Japan to do my PhD. After that, again, I worked in the private sector for a while, then went back to teaching. So my career is like between the industry and the academia until I joined UNU. My work as a professional started with the water resources, starting with the groundwater analysis. And then I worked slowly upwards in the unsaturated zone, infiltration, and so on. Then later on to the surface flows and how these surface flows are affecting the water resources and also disasters. And that leads to the important question of the rainfall impact on these processes. And especially in the developing countries, you realize that you don't have good enough information on the rainfall to assess the impacts due to impacts on floods or water resources or in agriculture. And that led me to the need to model rainfall processes. And in that, while doing that, I realized that the changes that's taking place to the climate, and so it's a logical transition from the rainfall modeling to climate modeling. I don't model climate as per se, but I use climate projections in assessing the impacts on water sector, especially in floods as well as on the agriculture. So that's my basic interest. And coupled with my previous background, I'm more interested in the global change. This is not only climate change, but also the man-made changes on the water utilization. So I coordinate this program, and I'm also teaching 2 sessions in UN-CECAR. The first one is on the downscaling approaches, and that's one of the most important element as far as the practitioners are concerned. That is, how do you relate the global climate change to your local conditions? As you know that we have the global projections, which are at a very core scale. So in this session, I introduce why the global projections are in a core scale. This is because the nature of mathematical modeling, which requires us to parameterize the various processes, and these parameters have to be applied to constant regions. This makes it necessary to have very small regions where the parameters or characteristics are constant. But in physically, we can't do that. So we average them and run these models in very coarse scale. But if you want to do some design at your local scale, designing a bridge or designing a waterway, road, you need to find out what actually happens at your local scale. To do that, we have to find a way to get this global information to the local scale. And in order to do that, we do the downscaling. And in this session, we introduce 3 different ways of doing that. One is what we call the dynamic downscaling, which is a nested process. The second one is through where we use a scaled down version of mathematical model. And third one is what we call the statistical downscaling, where we don't mathematically model, but relate the global phenomena to the local scale. So these are the 3 approaches. But then the question is whether that's enough for you to do the design. So we go through actual examples and see that we still have to do some corrections. One of them is the so-called bias correction, where the downscale products have to be corrected to match the local scale.